All right, this is the second part of distributions. Yesterday we did binomial distributions. Today we're going to look at normal distributions. All right. Yesterday we were talking about when the distribution was skewed or when it was kind of more evenly looking. Okay, it's skewed when your probabilities are different. It should be pretty even looking when your probabilities are close together. All right, so today we're going to look at when that happens. And when it looks nice and even, a better word to use is to say it's symmetric. And it takes on what we call this bell-shaped curve. And that's what we call a normal distribution curve. Now that's special, that's actually very common, like when you think of SAT scores or ACT scores, there's typically a mean that's kind of in the middle, and then you have some people that do better and some people that do worse, and it tends to fall in this normal distribution curve. It's kind of nice when your chapter tests do that. I feel like that was a good representation. They don't always do that, but on a standardized test like the SAT, they do typically fall like that. Other things would be like the lifespan of a battery or a light bulb. You know, they print a certain number of hours on the package, and then some batteries or light bulbs will last longer, some will last less, and it falls in this bell shape. Now, for it to be in this bell shape, it actually will have more than just that distinct shape, but what happens is the mean is always going to fall right down the middle of it. And then you go both directions. It's nice and symmetric, but you mark off 1, 2, 3 lines. 4 is kind of beyond it typically, and then you've got 1, 2, 3 lines this way. Those are called standard deviations, and we talk about how far something deviates from the mean. That means how far away from the mean does it get. Well, once you figure out what your standard deviation is, which we will talk about in a little bit, then we look at this rule here, and this rule says that it's kind of a dumb name, but it's called the 68, 95, 99.7 rule, and it says that 68% of your test scores or batteries or light bulbs should all fall within 1 standard deviation of the mean. Okay, 95%, okay, see if I can get rid of that. Well, okay, 95% of your test scores, light bulbs, batteries should fall within 2 standard deviations, and 99.7, almost all of them should fall within 3 standard deviations of the mean. Okay, these are important numbers. You need to know that rule. Okay, so what is a standard deviation? We're not going to take the time to do this. We're going to come back because we need these numbers, but basically a standard deviation this is how you compute it. It's kind of crazy, but we're going to compute it on our calculator. And you need to know the mean, and it looks like this. This is the notation for mean. We call it X bar. All right, and then this is the notation for a standard deviation. And the standard deviation is basically kind of how far does it deviate from the mean in even increments, so that when you get to the third one, that almost all of your data falls within that. All right, we'll come back to this where we use this data and we have to find those two things. One to start with. All right, now if 68% of your data falls within 1 standard deviation here, and it's symmetric, then really I could just take my 68 and divide it by 2, and I end up with 34% in each one of those. Okay, so it might be helpful if you just remember this broken down. Otherwise, you're going to have to redo this math over and over, which isn't a bad thing. Math is good, but you know, you just choose. All right, remember that 95% of the data has to fall within 2 standard deviations. Well, of that 95, 68% is right here. So what I do is I just take 95, subtract 68, and that gets me 27% still to use, but I've got to divide it over both of these columns, and so 27 divided by 2 gets me that 13.5. So this individual column will have 13.5%, and this individual column will have 13.5%. And if you keep with that process and go with the 99.7, we find that 2.35% falls here, and 0.015, hardly anything, should fall outside of 3 standard deviations of the mean. Now you might check your notes and make sure you have these numbers in there nice. Sometimes those notes don't print great. Make sure you get each bar's correct percents. Pause if you need to. I'm going to move on. All right, so let's practice building one of these normal distribution curves. Now I'm going to start off and do some easy numbers without decimals and anything, but the reality is a lot of the time when you're doing this, you have decimals in this. Okay, so the first thing we're going to do is draw a nice bell shape. Make it kind of big as what is in your notes. And it's just kind of off to the right of your notes there of this problem. It says build a normal distribution curve from 30 x values with a mean of 18 and a standard deviation of 2. Okay, off to the side is just my own note because I usually do it at the board onto the side of my Promethean. All right, so I've got 30, I'm going to call them quizzes. Okay, so I've got 30 quizzes. The mean is 18. Okay, so I'm going to draw this line, and I'm going to put the mean right down the middle, and that's 18. And then I should be able to fill in this normal distribution curve with 3 standard deviations, and at that point, I should be pretty much at the end of my curve. Now remember, these need to be evenly incremented, and they go by a deviation of 2. The standard deviation is 2. So if this is 18, this must be 20. This must be 22 and 24. But it also goes down, so there's 16, 14, 12. All right, so now you need to have this drawn because then we're going to come back to that for our and we're going to answer some questions about that, but I'm going to have to go to a different slide. Actually, I'm not. I'm going to stay at this slide, and you're going to look at your notes. Okay, the first question says, what percent is greater than 18? Okay, so when I look at this, what percent ends up being greater than 18? Well, that would be all of this up here. And since it's a very symmetrical curve, that's half of it. So you should have 50% that's greater than 18. Okay, let's go to the next question. The next question says, what percent falls between 16 and 18? Okay, well that's right here, between 16 and 18. And we already have that bar figured out. We broke it down to just 34%. Okay, the next one says, what percent is greater than 24? Okay, 24 is way out here on the end. The only little piece that's bigger than that is that 0.15% that falls out there. Last one, what percent is at least 14? At least 14. Well, that's this bar and all the way to the end. So basically, I'm going to end up adding all of those up. Okay, but wouldn't it maybe be easier to do the opposite? Down here, I only have that 0.15% and that 2.35. That adds up to 2.5. So if 2.5% is there, what's the rest of this? Well, I would just do 100 minus 2.5, and that would get me 97.5% would fall there. All right, I had to redraw it, so now let's look at this again. And the right side here, these next questions are kind of different. They say not what percent, but they're saying how many. So when you look at the how many are greater than 20, well, that's everything right here. How many are greater than 20? It's all of these. Now I could figure that percent. I would just have to add up my percents, and so you got your 13.5%, and you add in your 2.35 and your 0.15, and you end up with 16% that falls in that area. But the question isn't about the percent. It says how many. Well, 16% of 30 X values, or I said 30 quiz scores. Okay, so I'm just going to take 0.16 times 30 to see what I get. And so 6 times 30 would be 4.8. So I would expect of the 30 quizzes to be 4.8, so probably about 5 quizzes should fall in that range right there. Okay, let's try another one. How many would fall between 14 and 20? Okay, that's this right here. 14 and 20 is this range. Okay, so I'm looking just here, and I would add up those percents again. Make your life easy. You know that the first two in here, these two, are 68. Add in the extra 13.5, and you'll have 81.5% that falls in that range. And so if it's 81.5, then we take it as 0.815 times 30 to see how many that you think should fall in there. And you end up with 24.5. And so of the 30, you already have that many of them that should fall in that range. Okay, you try the next two. Figure out how many would fall between 20 and 22, and then find how many would fall between 12 and 14. All right, so this is what you should have gotten. That next one, the between 20 and 22, I have here in black, and then the between 12 and 14 I have over here in the pink. All right, let's look at another. Okay, so let's look at some real data. Now your numbers, again, sometimes those copies, the numbers get shifted. You might look at your X values right here. We're going to say these are a bunch of test scores. Make sure that yours match what mine is. So looking at that, basically this is how you'd figure that standard deviation. We're going to let the calculator do that. So let's walk through how do you enter that in your calculator. So the first thing you're going to do is take this list of test scores that I have, and you're going to put it in your list. So go to Stat, Edit, and fill in List 1 with those data points. Okay, pause the video, go do that. Then what you're going to do is you're going to, kind of like you're running a regression. Remember that you're looking for stats, so you go to Stat, and then you go over to Calculate, and instead of doing regression equations, what we're going to do here are the one variable statistics. And if you do the one variable statistics for list 1, it's going to give you all these great statistics about this set of numbers. The very top one there is X bar. Okay, remember that's your mean. And for this problem, you should have gotten an 83.7 for your mean. The other one, if you scroll down later towards the bottom, you should see something that looks like this. That's the standard deviation of your X values. Okay, so that's your, what I ended up with on that was 4.1. All right, so then what I would like you to do is to take those numbers, and I want you to a standard deviation problem where you're drawing the normal distribution curve. We already have the mean. We can fill this in. We know it's 83.7. We know the standard deviation is 4.1. I want you to draw out your normal distribution curve, put in these numbers, the mean, go up and down by your standard deviation, and build this. And then I want you to answer these 3 questions. What percent of the data should fall within 1 standard deviation of the mean? Okay, so within 1 standard deviation means either up 1 or down 1 would be within 1 standard deviation. And then change it to how many scores should fall there. And then I want you to go back and look at the list and see how many of the scores actually do fall within 1 standard deviation, and see how that compares to what we found was supposed to happen. All right? Then when you're done with that, I want you to try it again. Well, here, why don't you pause it and do that one, and then we'll check it. So pause for now, go do the work. All right, let's look at our results. So on this one, what percent falls within 1 standard deviation? All right, well, I've shaded it in blue. That's 1 standard deviation. Within 1 standard deviation should be 68%. I take that times the 9 test scores that were on that page, and that gets me 6.1 tests that should have fallen within this range. When I went back to the list and counted them up, I had 6 tests that fell within that range. So my 6.1 was a good estimation of that. So that was good. Okay, so now since I know you probably just cheated and you didn't do it on your own, now you really have to do it. If you just sit and watch me do all the work, you're not going to get the hang of it. You got to practice on your own. So try it again. This time I want you to find it within 2 standard deviations. You answer those same 3 questions, but do it within 2 standard deviations. Pause the video, you try. All right, this is what I got. You're within 2 standard deviations, that's 95%. Should have gotten you 8.6 tests that fall in that, and all 9 of ours did. So that's even within 2 standard deviations. That's why that 3rd standard deviation area is so tiny over there usually. All right, hope this helps. Good luck.